everyone. My name is Diana Chan Morgan, and I run all things community here at deeplearning.ai. Today, we have a very special speaker to talk about prompt engineering for open source LLMs. As you all know, your prompts need to be engineered when switching across any LLM, even when OpenAI changes versions behind the scenes, and this is why people get confused why their prompts don't work anymore. Transparency of the entire prompt is critical to effectively squeezing out performance from the model. Most frameworks struggle with this as they try to abstract everything away or obscure the prompt to seem like they're managing something behind the scenes. But prompt engineering is not software engineering, so the workflow is entirely different to succeed. So today in this workshop, we'll learn a lot about prompt engineering versus software engineering, open versus closed LLMs, push accuracy by taking advantage of prompt transparency, best practices for prompt engineering open LLMs, and RAG and how to implement RAG on millions of documents. This workshop will be recorded and the slides will be sent out afterwards. It is inspired by one of our courses that we have made with a speaker for fine-tuning LLMs. Our event partner today is Lamini. Lamini is the all-in-one open LLM stack fully owned by you. At Lamini, they're inventing ways for you to customize intelligence that you can own. And now I'd love to introduce our speaker, Dr. Sharon Zhou. Sharon is the co-founder and CEO of Lamini. As a former Stanford faculty member, she led a research group and published award-winning papers in generative AI. Sharon teaches some of the most popular courses in Coursera, including fine-tuning LLMs, and has reached a total of over 250,000 professionals. She received her PhD in AI from Stanford, advised by Dr. Andrew Ng, and before her PhD was an ML product manager at Google. She received her bachelor's from Harvard in computer science in the classics. Finally, Sharon has served as an AI advisor in DC and been featured in MIT Technology Review's 35 Under 35 list. We're so happy to have you here today, Sharon. Are you excited to dive into everything?
So happy to be here. Thanks for having me again.
Of course. Excited to have your little llamas, stick out and help everyone out. Everyone can learn a thing or two from them.
They may have been making cameos throughout certain deep learning short courses, so stay tuned.
Amazing. Well, why don't we get started? I'm sure everyone is super curious to learn everything that you have to teach today. And for anyone that has questions, we dropped a slide in the chat where you'll be able to vote upon which questions you want to hear from Sharon the most. All right, take it away, Sharon.
Fantastic. Yes, and please ask questions. Yeah, very, very open to that. And especially if it's, a little bit spicy, I kind of want to see some of those questions. Cool. So I'm Sharon. I'm the co-founder and CEO of Lamini. And I'll be talking about prompt engineering for open source LLMs today. As the title suggests, prompt engineering is not the same for closed versus open LLMs, and I'll go into exactly what that looks like. This talk was really motivated. I know Diana gave a really good intro on me, but this talk was really motivated by the pain that I had both seen and felt myself, and I just don't want other people to go through the same struggles. So this is to also step through some things that I've learned throughout this journey, and also I've seen a lot of people, a lot of smart people, kind of mess up and spend too much time on, like too many months on. So I believe in bringing people on the right path to success. Of course, this is these are my learnings. Of course, there are a few hot takes in there, and you'll see them very soon. So this should be a fun talk. Okay, yeah, my background, I think that was basically covered. But I was also the first generative AI instructor at Deep Learning. So I love generative models. I find them really, really magical. I also love people. And so my mission in life is actually just to make it possible for more people to be able to wield this magic that I basically fell in love with during my PhD. Cool. So just to go over a little bit, hierarchy agenda of what we're gonna cover. So first is, how is an LLM, how it was fine-tuned, or what was going on behind the scenes, behind the both API, but also before you started touching that LLM, what was going on before that has now impacted the way you prompt it. So what goes on behind the scenes, it does impact your prompt, and I'll go over exactly what that looks like. And there are different LLMs, and they actually have different prompts that do better on them. I see people saving prompts for GPT-4, for example, and thinking that'll generalize to other things, other models, and that's not the case. And actually, even different model versions, right? Like people have felt that deep pain around that. People think it's, oh, where is this backwards compatibility, which is a normal software paradigm, but you just don't see that here with large language models, and I'll go over that a little bit. Something I want to hit home also is that prompting is not software engineering, and I kind of see people really struggle with this because it's called prompt engineering. I think that was poorly named from my perspective. I think it's closer to actually running a Google search query where you're iterating over that query, and I'll just talk through exactly best practices, kind of what I've seen. Finally, prompts are just strings. I really, really do not want you to overcomplicate this. I'm gonna be super spicy about this and slightly snarky about this during this talk, but prompts are just strings. So if there's one thing that you take home is that prompts are just strings and you can handle a string, I guarantee it. Okay, and finally, RAG is a form of prompt engineering. A lot of people get that confused. They're like, prompt engineering versus RAG versus fine-tuning. And I'm like, no, this is a form of prompt engineering. I'll tell you why. It's because it just impacts the prompt. You're concatenating strings to a string. So again, do not overcomplicate so much. And I see people overcomplicating way too much. So this is kind of the agenda we'll go through. Who is this for? I mean, I posted this a bit on Twitter. This is largely for awesome, really smart software engineers. So I hope a lot of you out there are this archetype. You're extremely good at software engineering and you're curious about working with open LLMs. And it's a very exciting time to do that. And there are many, many benefits to working with these models that I can get into, but I'll just touch on a few that are relevant to prompt engineering in this course. And who's this not for? Well, this is actually not for people basically like me who's trained thousands of generative models and proposed new architectures because and trained them successfully. And that's because that process helps you understand why the prompt acts the way it is and why you have the prompt the way you do. I'm kind of, my view is you shouldn't have to go get a PhD, do all this stuff to understand this. This should be made more simple, and I'm going to try to go through how simple it is through this class. So I just want this to be simple. I don't want you to go spend so much time on a PhD. I want you to be able to listen to me at 2x and get it done in 30 minutes and be entertained. Okay, so let's start with a memorable analogy. This is really starting off really spicy. I was thinking about this last week. I was like, how am I going to communicate this? What is the best analogy? And I apologize, this is my best right before I fell asleep. So you go out every day, you're wearing pants, okay? Everyone sees you wearing pants. You see everyone wearing pants. You're told it's right to wear pants. Like it's the correct decision to wear pants. You are a good person for wearing pants, okay? Like you're just a good person. Every day you act normal because you wear pants and you see other people wear pants. You told this right to wear pants. You told this correct, moral even. But then one day you're not wearing pants, okay? You go out, you're not wearing pants. My question to you that I'm gonna pose right now is, do you still act normal? Right, do you still act normal? Okay, and this is maybe an extreme analogy, but this analogy is LLMs have the same wear pants feel. So LLMs also wear pants, okay? And that's via their prompt setting, and I'll go into exactly what that is. And remember that a prompt really just is a string, right? It's just a string. So a string, a lot actually matters for a string. Sometimes it matters more for the LLM based on how it was fine-tuned or trained than it does for us. But even for us, I think even small, edit distances within a string can make a big difference. For example, here's Jan LeCun's recent tweet of OpenSpace AI versus OpenAI. I know it's very spicy. So I'm just making this very spicy for you. So, very different words, different strings, only by a little bit of edit distance. So wearing pants is an analogy for a prompt setting, and every LLM, every version of an LLM has a different prompt setting, maybe not entirely different, but it's been adjusted to learn a certain notion of wearing pants. And okay, let's just go through a real example. All right, Mistral, one of the great open models today, very exciting model. okay, so let's say I want this prompt. I want to put this prompt in, respond kindly to the child. I really hate zucchini. Why should I eat it? Okay, to be fair, I really hate zucchini. Why should I eat it? I actually took that from my co-founder, who's awesome, but an adult. But I just say respond kindly to this child. So like, what do you expect? You expect it to respond kindly to the child, right? Okay, well, let's see. Without pants, what's going on? So without pants, it just like goes on in the third person. First, it's important to remember that everyone has food preferences and it's normal for children to not like certain vegetables. So that's just not good. It's slightly off, right? And we'll look at examples where it's way off, but this is just a simple example where it's definitely off. And just if you were to just let the LLMs, or you put the pants on the LLMs, it actually just responds to the child. And so I understand that you don't like zucchini, and it's okay to have food preferences. However, it's important to remember that eating a variety of good foods, variety of foods is essential for good health. Okay, it's not perfect, right? But it is better. And there is a shift immediately. And as you'll see soon, putting on pants is like super easy. Just like it is for you, it's easy to do for the LLM as well. Again, strings. Okay, same thing goes for llama. You're a health food nut. I'm drinking green juice. So you're just like putting this into ChatGPT. What do you expect? You expect it to be like, oh, like giving you advice, etc. Without pants, unfortunately, llama 2 here just like continues the sentence, right? And from my perspective, I'm like, oh shoot, it's not instruction tune, maybe. I'm a little bit, judgmental about it. It's like I'm also feeling a little judgy. Okay, it's just not good. This is like kind of, it gives like this off the rails feeling. And I know people are using LLMs at scale, and so just this difference where now it's able to respond. I know Llama 2 is very, very expressive. It's kind of hilarious, but it's very expressive. But this difference makes a huge difference at scale as well, right? Like when you're using these LLMs. So let me just share with you exactly what pants mean. Okay, so every LLM has a different notion of wearing pants. You'll see soon that you can actually have control over what the pants look like, but at a very basic level, every single LLM has a different notion here. And for Mistral, it kind of looks like this. For Llama 2, it looks like that. And what is exactly happening here? Well, these are called meta tags. So if you go to a party with OpenAI people and Anthropic people, you might hear them talking about meta tags. And what a meta tag is like here, these are tags, inside of your prompt that indicate something, about what the user put in. Okay. And for open LLMs, this is completely exposed to you or transparent to you or available to you rather, unless you use a framework. So I'll go into that later. But this is possible for you to just see and use. And yeah, let's actually, what I want to do? I want to dive right into it. So I think they can drop a GitHub link to you. I'm going to share my screen and just show you some code and just walk through exactly what do these pants look like. Okay. So I'm going to share a different screen. Okay. I believe I shared the wrong screen. Unless I didn't. No, I shared the right screen. I apologize. Cool. Okay, great. So this is an open source library, super basic stuff. Okay. It's like, oh man, just 50 lines of code, 60. So really simple stuff. All it's doing is I am running a couple open models. So first I'm going to run, Mistral with you. And then I have a few prompts here, kind of just like the green juice one that we talked about, the zucchini one we talked about, maybe a couple others. And these are actually real ones I just grabbed from my own history. So like I did not spend that much time on this, but it's pretty apparent. It's pretty stark difference between using the putting pants on or not. And so all I'm doing is iterating through, printing what the prompt is, letting the model, generate based on that prompt. And then I'm adding pants on, right? Pants on here, printing out the pants with it and letting the model run it with, with pants on. And then comparing them. Same thing with Llama 2 here, doing the same thing. And here there's something, kind of fun with like the system prompt and the user prompt. Cool. And you'll see here, I do, some kind of, this is my own personal convention. And again, these are just strings. Like all you need are F strings. And these are just like max 30 extra characters that you need. So I just don't understand why people need like extra frameworks around it. Okay, so here, let's focus on this guy. And I just ran it up here, but I actually am let's just run it live. Why not? So let's do this. Let's import. This is a class that runs different models. And so I'm just going to run Mistral here. And which one? So I know we kind of looked at those other two. So I'm actually going to do the code ones because I actually thought those were really interesting since they made a massive difference. And I know that people are kind of working with code. So if you were to do this here, let's see, let's run the model with just, okay, oops, let me just say prompt equals this, okay. And then I'm going to run the model. So this is how you run the model, lm.generate, okay, and just that, and no pants on, okay. Great, and then I don't like looking at new line symbols, so I'm just going to run print. All right, so totally off the rails. Great. So VS Code. This is something again I wrote into an LLM so previously. So like how to find code that's been checked in a long time ago, e.g., more than 6 months ago. Yeah, I was trying to figure that out. But then here's just a kind of a disaster. Like what is going on? I have a large code base. It just starts to think it's me, and then this git log stuff as like what is happening, right? All right, so let's put some pants on this guy. Let's see. Okay. And actually, just one note here, I find it really interesting that, and people don't know this as well, but like really interesting that, just a single space here, this matters a lot. And just like a fun historical note, back when GPT-3 was out, but no ChatGPT. So like this was circa 2020, and I was playing with these models. It was so interesting because like you would end your whole thing with a space. Like imagine like if you ended your question to ChatGPT with a space, it would go completely off the rails. It'd be no pants on already. So like very sensitive. Now models are way less sensitive, including open models. So it's kind of exciting to see it. But before the pants thing used to be more extreme. Let's put it that way. Okay, so let's actually do this. But yeah, so I just found that like historical note really interesting. We can even run it with and without a certain space here. Like if you want to run it, okay, not here, but like if you want to change what the pants look like. Oh, sorry, I need a print. If you want to change what the pants look like and you remove a space, it should give you actually a slightly different string. So just know that these things are sensitive to the strings. It's less sensitive semantically, if you were to embed everything, but it's still going to give you something a little different. Cool. And happy to go into the machine learning reasons why, but just so you know, it is different. So yeah, here, much better. Wow. In Visual Studio Code, you can use the built-in Git integration. You can do all these steps. It's possible. This is actually not totally true, but like this is like a valid response. Like I would be like, yes, I'm talking to someone who is wearing pants is kind of my thinking. Great. Okay. So you can run a bunch of these also on your own. This other one, this example JSON file, I also was running this on my own. This is just kind of, I literally, this is like literal code I have I've written and I needed help with. And it was a dramatic difference. And maybe I'll just scroll up to go look at it for you. So like what the script, just so you can see what the script actually outputs. So it would be something like, let's see. So like here, prompt, this is adding pants on, then it's actually like producing code, like legitimate code. Versus when you don't, it doesn't do that. I can actually just run it like that for you to see. But yeah, I just find it just interesting that I think people miss this and then they think these open models don't work. And That's actually really unfortunate because they do work. They actually work very well, and you can get like just a massive performance bump just from knowing this. So this is what the exact script does in the open source repo. So you can just say, you can see the prompt, then you can see the prompt with pants on, you can see the response from those, and yeah, you can see like why are you saying a colon, like stop. I actually know why, but it's fine. Let's see. So yeah, this is off the rails. This is better. Let's see. Great. Okay, cool. Cool. Here, I'm gonna go back to the slides. I think the point was made. But feel free to play with your own. There are definitely going to be things that are a little bit more sensitive, things that are going to be less sensitive, but just something to note if you're using LLMs that way. Great. Cool. So the learning is, if you didn't get it the 10th time, is LLMs want to wear pants. Okay. So like give them the pants to wear. And you might be wondering, okay, well, why didn't I know this? Why have I been basically abusing my LLM and not letting it wear pants? Well, it's actually pretty poorly documented. It's not really in a lot of official releases. It took actually our team a bit of time to find as well. It's just not, it's also when it's not official, you're like, is it, is that the right one? Is the one that like, because AWS was like a partner with Meta's Llama release, like, is their blog right? So, a lot of questions there. I've also worked with folks who, this is terrible, but they were like, oh, our model does so much better than the base model. And I was like, well, I got better base model results than you. And it's because they got the pants wrong. And I was like, so your model's not actually better than the base model. So it's important to know that. This is not something you need for closed LLMs. I'll go over that with you in a bit. You can argue it's implicit lock-in, right? So they like manage it all for you. I think it's also so that they can push out new versions. And I know that people don't like it when they push out new versions and update things behind the scenes because it's not transparent. At the same time, the argument is if you were to create your own, you probably would do the same because the software expectation is you don't want to pip install upgrade, every 5 minutes when these models are constantly learning. So there is a trade-off here, to be fair. And you also thought your framework could handle it correctly, and a lot of frameworks don't. And I've been guilty of doing that. So just getting the string representation right isn't always the easiest, but it's making it transparent, I think, can help you get just a few extra characters in, like 30 extra characters. So yeah, on to why it's different from closed models. So ChatGPT, you can text ChatGPT. You don't need to add pants to it. It chooses to wear pants behind the scenes. So OpenAI is putting pants on behind the scenes. So this is actually, what the API looks like. You are putting in I would say dictionary here, but mainly this string of content, right? And what's happening behind the scenes, this is my guess. This is not actually it. I mean, if this were, that'd be kind of weird. But so like maybe there's a role thing going on here. Maybe there's a message tag there, right? But there's some representation within the string that they're doing behind the scenes. And, if I were them, I would probably make those representations single tokens that they've figured out, kind of like an endless sentence token, so that you can like represent it very minimally in the prompt to be token efficient. And so this is a guess. I don't know exactly what it is, right? But this is kind of what's going on behind the scenes. And this is why you don't think about it when you're working with closed LLMs, right? So you don't think about it. And if you're shipping your own closed LLM, like this is also something for you to think about. Like this is a trade-off, right, for your user. On the one hand, it is kind of gnarly to look at those tags for like a non-engineer, non-software engineer, and you can't wrap it in a beautiful interface. But on the other hand, it does help with working with them. And I think there's real benefits to understanding that those exist and what they're used for, right? Why you need them. So something I just want to hit home is at the end of the day, though, all you're adding to the string, you're like, oh, wow, great. ChatGPT handles it for me. Well, like on the one hand, yes, it handles it for you. But on the other, it's like, it's just a string. It's like 30 extra characters. You can do it. I believe in you. I believe in your ability to be able to concatenate strings. And, I was trying to look for, what level is string like working with strings. It's actually a kindergarten level. This is from scratch. So like no excuses. If you're a software engineer, no excuses for not being able to work with strings. Okay, great. So let's see. 80% of frameworks overcomplicate the string though. So I said, do not overcomplicate the string. 80% of frameworks get it wrong. It might be a few characters off. It might be completely buried somewhere. So this is LangChain. I know I'm calling them out, but I'm actually guilty of it too. So I shouldn't just be calling out other people. I've been guilty of this too. Our team kind of built a kind of type system to make it easy to work with LLMs, where we like converted your type to input output types. That was very Pydantic. Using Pydantic is very Pythonic, and so a lot of software engineers are like, wow, it was awesome. I got to work with LLMs this way, but to be honest, it was just totally overcomplicated, and we spent like months ripping that out over time slowly. And so I just don't recommend that. And so that's my learning from the pain that I've seen. And I think there's, I don't think it's intentional. I think it's to, help with working under normal software paradigms. And I think that's valid. I think there are better and other ways to do that where the prompt doesn't get totally buried. Because at the end of the day, you're going to maximize performance when that prompt is transparent. And you're able to verify as the person running it that all the characters are in the right places. And if we were to go a little bit more advanced, I would tell you ways how to veer off of those pants and maybe change the color of the pants to follow the analogy. But like this, or wear a skirt. But yeah, so it's I think it's important to keep the prompts transparent, especially for open LLMs. Cool. So the learnings, keep the prompt transparent. Wow, I'm so ahead of myself. So make them easy to change, because every new LLM, you're going to change them. That's for every new version, every new update. I don't know if this is the case now, but for a very long time on Hugging Face, new versions of models, and this was just last summer, new versions of models would come up without people saying anything, without the creator saying like, oh, we pushed a new model to the same name, so it's going to be the same one. It's just so yeah, there's no backwards compatibility on that when someone else is owning the model. So just note that does happen. So it's the same thing as OpenAI changing versions without changing the name. So just know that. So prompts are the highly variable part of your workflow. So I want to make sure that you understand why this is important. Like, because it's so highly variable, it needs to be transparent and easy for you to access, to be able to iterate on it constantly. And it's not a pain, it's a string. So like if it's not a pain in the butt to do this, it is a string, you can do it. And it actually gives you a lot more flexibility in terms of working with these models. Okay, so we've gone over a few different things. I feel like probably what's on your mind maybe is who decided how the LLM should wear pants? Like maybe you saw, okay, well clearly OpenAI decided some things for their models, and maybe Meta and Mistral decided some things for those models. But who gets to decide? And I'm extremely opinionated on this. I think everyone should get to decide at some point. And I think it depends on your application. And, it depends on like what level you want to be able to make that decision at, right? Like maybe you do want to make it at the same meta level, but maybe you want to make it at a higher level, right? Like you want to add another prompt setting. You want to add another notion of wearing pants for this LLM. And the way to do that, like the standard way of doing this is fine tuning LLMs. I also do teach that class, and I plan to teach a class that goes into that more in depth for software engineers. But essentially, that's how you can decide the prompt settings, because it shifts the knowledge and behavior, and you choose what those meta tags are. And who decides, this is why in closed LLMs, that's why you feel like your prompts are breaking or not backwards compatible. It's because someone else is deciding how to wear the pants, and things just shift a little bit for every update. There are actually infinite prompt settings you could target. Infinite, and they're all just represented in strings, so it's actually not that hard. So we looked over chat. So those were chat templates, essentially. I call them prompt settings because the phrase prompt template is just so overloaded and used for other things as well, like not for this. I've seen chat template. I've seen I think Mistral released something with, or Hugging Face together with Hugging Face, they released something to help with managing it. And I do think when it's very simple and you can verify it, it's okay. But you can also, produce JSON outputs, right? You can function call, it's all fine. These are all prompt settings you yourself could target and control. I added this one because I thought it was fun, because one of our customers was kind of fine-tuning a model towards menu items, because they're extracting menu items from a conversation that they're having. If you imagine like a drive-through window kind of thing. So it's kind of fun. So you can do anything. Like what I'm trying to say is like you can do anything, not just like the standard stuff, right? So like whatever format you want. So you can use fine-tuning, and what that does is have your model view another setting as wearing pants. Or you can have it forget a previous setting. You can do whatever you want, basically. So kind of a powerful tool to do that. I kind of want to add this like little tidbit of something a little bit more advanced for those who are watching, who are a little bit more advanced on this. You can actually get a model to think it's wearing pants without fine tuning. I call this Emperor's New Clothes, if you know about the myth or whatever it's called, the story. And I actually built this, our team built this, and we have this custom inference engine that is able to take any model and without any fine tuning, be able to actually produce guaranteed JSON output. And so you can actually basically force some pants on. It doesn't like fit really well, or you kind of trick it into it. But you can get guaranteed JSON output. So this means, when I say guaranteed, I mean like 100%. Like it is not like it's not even probabilistic at that point. So yeah. Cool. So the learning here is that, maybe you're like, I just don't want to deal with this. And lazy use like, I just need someone else to manage 30 extra characters, or like 10 or something. Okay, whatever. I'm going to stop ranting about that. But curious use, like, I actually want to control this. I actually want to understand this better. I actually want to push performance. It's okay to be lazy. I can be lazy too. For different use cases, you want to be lazy. Like if I'm just like randomly asking a question. In other use cases where you're building your own, maybe for your company or your side project, etc., you do care, right? So it depends. And usually I transition between, I start lazy for everything I do, and then I move to curious. So prompting. One strategy for prompting that I just want to make sure we hit home here is around iteration. So for software engineering, how do you be a good software engineer? Okay. You create a good design and you implement it. Okay. And a lot of your time is in creating that good design, right? And then implementation. Like some people are like, oh, get up Copilot, not going to replace me, because most of my job is just designing, architecting, right? The code, the system before I write the code for it. Great. And 80% of devs I meet are actually prompting like their software engineering. So I actually find that, some random person off the street might be, I'm not saying actually is, but might be better at prompt engineering. And I find that just so interesting because for prompting, there's no such thing as designing the right thing. You can't take a class and be like, can't take this class, ready? You can't take a class or this class or any class and say like, I'm going to do exactly these exact things that they said. Because at the end of the day, it's a very, very iterative process. You're not designing it right and being perfect and then implementing it. You actually should just give something bad. You should actually be lazy. You should be lazy. So like you should give something bad, just like when you're Googling, you know how you don't even spell things right sometimes. You just be lazy and like iterate. Oh, Google didn't understand what I said. It didn't do the, did you mean this? It like totally didn't understand the random keys I pressed. Great. So let me like iterate on that, make it better. And so that's the mentality you have to go into the whole thing with prompting. And because it changes so much across different models, versions, etc., you want to be able to have control over that, right? You want to have transparency over that, and you want that to be easy to access. So there's constant prompting. Yeah, exactly what I said. A good enough strategy. So I see a lot of people plateauing and having trouble realizing that like the best strategy might just be to time box it, and to realize you get diminishing returns. And I think the way you do that is prompting iteratively to learn that. Like naturally, you'll just do this. So figure out the time. It's probably 1 hour. Figure out the time though. So and invest that time into it, and then get diminishing returns after 100 iterations in that 1 hour. Okay. So just like you're Googling, like really not anything different. Don't spend so much time just designing it or like watching all these videos to design it. And again, because the prompt settings can change, like things can change, it's good to learn this skill, and it's good to make this very easy on yourself. And so, yeah, I just think it's make it super easy in your code base when you're working with models, to change these prompts, because you can't leave it stale. Unless, of course, you're controlling the models themselves, you're fine-tuning themselves, you're checkpointing themselves, and that's actually one of the big benefits of open models, right? So you can control when the versions upgrade. So the learning is prompt engineering is neither software engineering nor is it machine learning. I can also guarantee you it's also not machine learning, despite all the papers these days of like people publishing prompts. It's just not. Yes, there are some fun things that you can learn about the prompt where you can think step by step, for example, but it's not machine learning. So this is all the stuff you put into the string before you actually run the machine learning part, before you actually run the model. So again, just string manipulation, kindergarten, scratch. Cool. Let's move to RAG. This is also something I find people trip up on. They think it's a completely different thing from prompting, but I think it actually is a subset of prompt engineering. It's a way to prompt things. So RAG is search. It's information retrieval. It's been around for decades, actually longer than AI, way longer. And speaking of like prompting like Googling, Google is the best at this, at search. And so there are a lot of good practices, a lot of best practices that you can employ from decades of research and also decades of real production deployments. It is at a very basic level, and I want to, again, hit this home because I think people get a little bit intimidated sometimes, or they think it can do all these magical machine learning things when it really can't. It's just concatenating more strings to your string. So don't overcomplicate it. And also at the end of the day, it actually is good to have transparency around this. I see people running big workloads without any transparency, without seeing their prompt at all when, they bragged it and added relevant content to it. And they could have been debugging there at that level. They could have caught so many bugs, right? Or ways of just representing the data differently, adding a title, adding a header, some other meta information within every single chunk. So don't overcomplicate it. Like, you can do it. You don't need a PhD in machine learning for sure, because it's not even machine learning. So great. So I put together a really simple repo for us to go over, and kind of the goal of this, I say 80, I think it might actually be 70 now. Kind of proud of that. But so the goal of this is to make it look simple, but also to actually just see how simple it is. And yeah, kind of go through what would this is, I mean, obviously, kind of like how a machine learning person would go about it, because I'm using Feist. But essentially, how would I go about doing RAG? So I'm using Feist. This is an incredible library by Facebook, or Meta, and it's been out for a really long time. I should have checked exactly how long, but way before ChatGPT. So it's for similarity search. It's kind of their embeddings library to be able to handle embeddings well. I'm importing some standard libraries. I'm also importing our embedding API to be able to hit embeddings really quickly, and also being able to run a model on the outputs of something in RAG. So like after your whole prompt has been basically compiled or created, with RAG, be able to run the model there. Okay. So exactly what's going on here. So I'm just going to step through code so that it all looks transparent. And again, 72 lines, and this part is just running it. So cool. Cool. So loader, this is just loading data. I'll show you what that looks like. Build index, this is an important function to understand. So really it's grabbing different pieces of content inside of your data. So maybe you have a TXT file, with data in it, and you're loading it up. So let's say, I know there's another file, maybe it's cheating for the 80 lines, but all it's doing is chunking and loading. So loading files, I'm putting the chunks in batches just to be more efficient, and then chunking the files and chunking each file. Cool. And then you iterate through that. These are batches, right? And what you want to do is just like get embeddings of them. And you get embeddings of them. So these are vector representations, aka just like numbers representing the semantic understanding of every chunk. Is it perfect? No, right? It's not perfect. It depends on what you give it. Maybe you can give it extra information so it can represent more. I know there are a lot of techniques about, what best way to do it. There are a lot of different indices you can use, and you're welcome to go look into that. They often are trading off things like, this is a really simple one for our purposes, but they're often trading off things like, memory or efficiency versus accuracy. So a lot of different techniques there that have been around for decades, and that people are using today. And I think like the best ones are not being invented today. The best ones were already invented a decade ago. So or most, most popular ones, certainly. So I'm putting that into that index, adding it there, and that's all I'm doing. And then here, all I'm doing is extending this list to include the actual content so that I can retrieve it easily. That's it. So I get the embedding. It's basically a representation between the embedding here, semantic understanding of your chunk of data, and then being able to actually get the data associated with it. Okay. What's going on in embeddings? All it's doing is similar to calling a model. So you can do that. This is probably going to be your biggest bottleneck in RAG. It's not going to be building this index, I don't think. These models are getting larger and larger. Of course, you can get away with running smaller models, right? So I think throughput here matters. And so here you get over, I think, 50 QPS. So that means like 50 chunks per second can be run through this. And being able to do that quickly and efficiently is how you get, how you basically can represent it. I know people are using vector stores, right? I don't know how I feel about that long term, but the thing is, unless you need more than a terabyte of data, I feel like you may not exactly need to actually have that vector store, because at the end of the day, you can fit into the model. I mean, the model was able to fit the internet inside of it. Cool. So query exactly what's going on here. So I'm getting the embeddings. All I'm doing is representing it as an array to be able to feed into this index to be able to search it and grab the right chunks. And here it's like k equals 5 for this particular type of index. It has a parameter k, which tells you I want the top 5 essentially here. Great. And there are lots of different methods, right, to trade off between, I want the top 5, but I want them to be diverse 5, right? Like I don't want them to be all the same, since there's a lot of repetition in my data set. So things like that. And I think like, yeah, we're just scratching the surface, but it doesn't get much more complex than all those things. Query engine. So this is just, I'm breaking the code apart in kind of best practices of how you usually do information retrieval. So there's this index that you build, and then there's a query engine. And here what the query engine is doing is it's running a model, right? So like first you query the index, and then I'm putting it now through the model. Before it was literally just this. Before, back in the day, before we used models, it's just like, let me get my closest documents, and then Google surfaced the closest documents. Now you can put some close documents into your model and be like, can you, Englishify this for my user and actually reason over it. And so that's very exciting. And again, I'm adding pants here just to hit that home. And finally, this is, you don't have to necessarily have an extra class here, but just make it easier. So a runner where you can load the data, set K, be able to play with that number, be able to, training, quote unquote, be able to build the index during that, and then calling it with the query engine. So what that looks like is just instantiating that class. I'm sorry, every time I hover over it shows extra stuff. Instantiating that class, saying, hey, grab everything in the data directory. I'm just timing it. I'm just kind of curious how long it takes. Do that training, which is building the index. Some indices you actually do have to train. Just note that a little bit when they want to like find some centroids, not exactly centroids, but yeah. And then here, all I'm doing is making it easy to talk to the model in this format. Oh, and I already ran it. So it's kind of what it looks like when you run it. Great. So ask an investment question. Sorry, this is like super dummy data. So it's grabbing chunks here. Let's see. Great. Elon Musk. Okay, cool. And then, yeah, the model's able to produce it there. And then you can keep asking questions, whatever you like. Yeah, and I think what's important here is that it is simple. You should just be able to run this on your own. You should be able to swap different models. You should be able to swap different ways to embed or different indices. That should be really, really simple. And I don't see why anyone can't do that, especially with library like FICE. I think it makes it really powerful. And then, of course, some kind of good embedding model. And I know that people are experimenting with a lot. So that's an area where you can experiment with a lot as well. Okay. Okay, cool. And this is open source, so feel free to play with it, do whatever you like with it. Yeah. Okay. And back to the slides. Cool. Okay, so you saw that. I think I probably wrote 80 lines because I was like, it's 80% of the way there. But I really do think it is. And I'm not always convinced that the last 20% is worth it for some applications, right? Like some applications, maybe, yeah, you just add a little bow to it and it's done. But I think you should be able to max out in like what I see is like four hours if you know how to actually use this technology. So the idea is don't overcomplicate any part of prompt engineering. You're just working with strings, including RAG, actually. So you want to be able to print and see those chunks, right? Like maybe you saw those chunks and you're like, actually, that's not what I expected. Or maybe I can represent different chunks. Maybe I can add a little bit of extra metadata. Like it should be pretty obvious when you're adding that to the model in the string representation, what a model would do with it, especially if you've been iterating hundreds of times on real prompt engineering, if you've been taking that actual approach. So if you take that iterative approach, you'll start to realize like very obvious ways you should be adapting your data for it. And I've seen some cool techniques of running or pre-processing data essentially through other LLMs, like a pipeline of LLMs, to be able to represent it in a different way. So feel free to also play with that, but it should be obvious from iteration that you like what extra data you might want to include in it. And I've seen people put like, oh, I need to put section headers in here because of course, like how does it know what clause 8 means when it was part of this document, or I need metadata on the document it actually pulled from. I'm pulling from multiple documents, so that type of stuff. So it should be pretty apparent, and you don't need to read like 10 blog posts or like use a framework to get it done. It's a string. Okay, so test your assumptions. Does RAG actually get it right? Might not. Okay. Does Google search get it right all the time? No, that's why people are using ChatGPT. Just kidding. So yeah, so if you put in that much effort, you can actually keep going and get Google level at search before the LLM. I personally don't recommend that because I think there are so many more things you can push on the LLM side. Like just get it to work when your retrieved content sucks. Like you can actually make that happen. Just like stop retrieving things. You can actually just put it all into the weights of the model. It learned the internet. Why can't it learn a few more documents or millions of documents? And your biggest bottleneck is that embedding call, right? That is your biggest bottleneck. So being able to get good throughput on that, I think, is important. And so at least here, like to help with customer loads, we've been pushing on that like dramatically to make sure it's possible for people to actually run heavy loads and heavy amounts of data through it. Okay, yeah, I think frameworks often make it harder. So if a framework is like making the prompt more opaque, and whether that be the prompt with or without RAG, right? That's not good. That doesn't help you, especially with open models, especially from moving from a closed source model that you've been playing with to an open model. And you think like, oh, wow, all these claims that, Mistral is better than ChatGPT in some ways don't seem right. Well, maybe you didn't put pants on, like maybe you didn't do RAG right, like maybe you haven't been iterating correctly. I generally believe it's always user fault, but this is something that I've just observed, especially those who come from a software engineering background, like myself. Cool. So what are the key takeaways of this talk? It's one, keep your LLMs pants on. Like, and now that you know what it is, now that you know what it is, keep them on. And that's how you can get normal or expected output and performance. It's because it's been fine-tuned or trained that way. Like Meta and Mistral actually train their models to learn those tags in that way. And so it also expects to output in that way. Prompt transparency, this is your biggest advantage. It's easy, it's just strings. Don't overcomplicate it. It's just strings. And make sure that when you're organizing your code base, wherever you're working with LLMs, that you do get prompt transparency and that you do manage your prompts in a way that everyone can touch it easily and find it easily and print it easily. Okay, so like very important, and that should become very evident if you're iterating over the prompt. And so those go hand in hand. All of this, just all of it goes hand in hand because you will keep the pants on if you keep it transparent and make it that and actually iterate over it. Cool. And then approach it iteratively. Like I was saying, it's like Googling something. Start lazy, start bad, and just get it better, and just time box the time you actually invest in it. Cool. And I think that is it. Oh, feeling more advanced. Just kidding. There's one more. Feeling more advanced than strings. Yes, you can customize your own prompt settings with fine tuning and choose what strings are the pants for the LLM. Great. Okay. And that is it. Thank you so much for listening. I will take questions or maybe I was supposed to listen to questions over here.
Perfect. Well, thank you so much, Sharon.
Yeah.
I know our community really learned a lot, and this has been a really informative session. I do have some questions prepared. I know there's going to be so many from the audience.
Okay, yeah, no problem.
We'll start with the first one and see how many we can get through. So our most top voted one was, should the system prompt of an LLM for a non-English app be written in the target language or in English and ask for responses in the target language?
Okay, I'm going to go back to my point of iteration. So why not try both, right? Like you should be able to try both, because at the end of the day, like the reason why I'm saying it's iterative, the reason why I'm saying don't design it up front is because for a lot of the behavior of the models, we don't fully know how it was fine-tuned behind the scenes. So I actually can't tell you up front, it's an empirical thing. So I actually encourage you to try both. And the way I can give you a framework for trying both and being able to determine which one's better though. So the framework I can give you is maybe 30, maybe 100 if you're feeling ambitious. So start with 30 or 20. The 20 examples of running this, and where you change the system prompt to be English or non-English, and you basically A/B test. Okay, so like that's the framework for doing it. And these models are very empirical, and it is on a per model basis. Because I know different models are trained on different languages. I think Mistral is trained on more languages, for example. Yeah.
Perfect. Okay, I think our next question is, what should be the approach for understanding prompt engineering for the LLMs that are going to be released in the near future? Examining training sets, etc.
Oh, I see. For a lot of prompt engineering, I think, as much as the creators can tell us about them, and maybe you're a creator, like whether you're a Meta or not, I think actually more people are going to be fine-tuning and building LLMs in the future. So I think the more the creators can be transparent around, maybe the training data, or also just like what the pants look like at the very bare minimum, one, I think they're incentivized to do that. Like, I'm actually confused why they don't release it, because it actually helps other people see the amazing performance of these models. So I think the approach for those releasing it should definitely be releasing as much information as possible, and going beyond just like open source weights, and definitely showing what pants look like for this model. But yeah, I think the approach is the same, like, because it's empirical in terms of what's been trained on it, what's been done to this model. You have to test it, and the way kind of I go about it, the framework I go about it, is having different test sets for different use cases. And I think this is why I'm kind of excited about models that are going to be more specialized, because I think you could actually have real test coverage over a specialized use case, versus saying like it has to be general, it has to do everything, even things that contradict each other. It's a little bit harder when that's the case. But yeah, but of course you can always do fancy techniques, examining the training set, and doing things like that, being like, oh, it covered these modes, aka it covered modes are just like modes and distribution. It's like covered these topics, so you could do that, for example.
Perfect. Recently upvoted very high. Can you provide
more
examples of different pans?
Yes, thank
also
you.
known as meta tags.
I don't know if you understand. Okay, I think people here understand the pans, and I deeply appreciate it. I'll reward you with some llamas on screen. Okay, let me actually read the question, because I'm a little bit flustered about how great this is. So can you provide a few more examples of different pans? Oh, okay. I think the most important, like, this might not be like pants, but like pant leg, like if you were to extend the pant. Okay, sorry, this analogy kind of breaks down at some point, but is multi-turn. So what I didn't share with you was multi-turn, right? I didn't share it. So like this assumes no chat history, and it looks a little bit weirder with it, and honestly, like kind of unintuitive, because the creators chose it. Like it's probably they chose it. So it's a little bit unintuitive. But yeah, if I can think of it off the top of my head, I can try to do it. But basically, yeah, I can share that with you. I can add that to the repo if that's helpful. I would say that aside from the ones I shared for those models, I don't know, because those are things I found in like slightly unofficial but slightly official ways. And this is where I wish things were a little bit more transparent around it, right? Like it'd be easier to see it. If you saw the training data, you would definitely see it. I've tried, hacking these models to see if they would leak the prompt to me. I didn't try very hard, but I'm sure there are ways to try to go about that. So yeah, I think aside from these, there are not like any super known ones for these couple of models. That being said, the multi-turn thing, and it's possible they didn't train beyond that. Does that make sense? Like it's also possible they didn't have a template beyond that. It's totally valid to do that. And maybe just to give like one level deeper detail. So as a creator of LLMs, what you would do is you think about, well, what control do I want my user to have, right? And so the llama creators probably like, I want there to be a system prompt. I think that would be pretty cool if there was a system prompt, because it seems like slightly different. You tell the model to take on a different identity, as opposed to like you're having a conversation with the model, right? So they trained on, I know there's a default system prompt, but what they did was they fine-tuned on a lot of different possible prompts to get a distribution, so that when you put in a system prompt, it doesn't only know one kind of system prompt. It can actually adjust the model towards that system prompt. So it's important to, when you're fine tuning in that case, get a good distribution over what you would expect your users to do with it. I don't know if that helps.
I'm sure it helps them a lot. Last question. How can we address ambiguity, context shift, and the correct semantic nature of the prompt given to an LLM?
Let me see if I understand that. Ambiguity, context shift, and the correct semantic nature. I kind of want a specific example from this person.
That'll be tough.
Okay, yeah. Sorry.
There's people watching.
How do I address? Oh my God, it's a little bit meta. I'm like, this question, this prompt to me is ambiguous. But I mean, I can make some assumptions and see if I can answer something. So, I mean, my response is you should be less ambiguous. But I don't know what the person's looking for, quite frankly. So I'm sorry.
That's okay. That's okay. Well, I think that's perfect to wrap up then. Thank you
Yeah.
so much, Sharon. This has been an amazing session, and we'll definitely have to have you back and some more courses and llamas,
Oh
popping
yeah.
in from anywhere. But feel free to, register for our next event. We have so many things coming up for our courses and many other things with deeplearning.ai. And we'll see you guys next time. Thank you, everyone. Bye.